Science Lesson 4, Evaluating Scientific Explanations. Page 27. Our objectives for today: students will evaluate scientific explanations. Students will evaluate promotional claims. Believe it or not, look at the photo in figure 24, the UFO. Do you believe what you see? Do you believe everything that you read or hear? Think of something that someone told you that you didn't believe. Why didn't you believe it? Chances are, you looked at the facts that you were given and you decided that there wasn't enough proof to make you believe it. What you did was to evaluate or judge the reliability of what you heard. When you hear a statement, you ask the question, well, how do you know? If you decide that what you are told is reliable, then you believe it. If it seems unreliable, then you don't believe it. A couple of the examples on the page here show things that are sometimes believed and sometimes not believed. This is a picture of Bigfoot or Sasquatch that was supposedly taken by someone as evidence of this creature's existence, and oftentimes sparks all sorts of controversy to say, yes, Bigfoot is real, and yes, he exists out there, Sasquatch is real, or no, he doesn't, this is completely fake, this is just a person in a suit. Some people don't believe in dinosaurs because people find just the remains of those dinosaurs. There isn't actually scientific observation of those creatures that lived. Some people believe what's in the media and what is portrayed to us. I like to say that the word media stands for giving me an idea. Others like to bash and say that certain industries are fake news, or things that you see on the internet or social media can be a source of unreliable information. What science offers us the opportunity to do is to do some critical thinking to judge what it is that is in front of us. When you evaluate something, you use critical thinking. Critical thinking means combining what you already know with the new facts that you are given to decide if you should agree with something. You can evaluate an explanation by breaking it down into two parts. First, you can look at and evaluate the observations. Based on what you know, are the observations accurate? Then you can evaluate the inferences or the conclusions made about the observations. Do the conclusions made from the observations make sense? So there's two parts to scientific evaluation. Evaluate the process of the science, how it was observed, and then evaluate the conclusion that's made to see if your thinking aligns with both of those in the form of critical thinking. A couple ways in which I'd like you to practice critical thinking that are going to get us to be thinking outside of the box. Number one says, how is the moon like a dollar? How is the moon like a dollar? It's a little bit of a riddle that causes some critical thinking to say that, well, there are actually different phases of the moon, and guess what? There are 4 quarters to those different phases in the moon. So a moon is like a dollar in the form of it having 4 quarters. I bet you didn't think of that. Number 2, how many books can you put in an empty bag? Well, you're probably thinking, well, maybe it depends on how big the bag is, how small the books are, all those variables that would go into how to answer that question. It's a lot simpler. It's an empty bag. If it's an empty bag, then guess what? There can't be any books inside of it. Now you're getting the hang of what this critical thinking looks like from the standard of what is being observed and what is being concluded upon. Number 3, how many times can you subtract 6 from 60? My mathematicians out there are probably saying, well, 60 divided by 6 means you could subtract 6 10 times to get all the way down to 0. Incorrect. If you take 60 and subtract 6, you get 54. You're no longer subtracting 6 from 60 anymore. You're subtracting from 54, so you can only do it once. Interesting way to think about something a little bit differently. Number 4, what's the next number in this sequence? 31, 41, 43, 47, 53. What would come next? Logic says that, well, this is plus 10, plus 2, plus 4, plus 6. Maybe it'd be plus 8. We'll leave that as a little unknown to kind of rattle your brain as we continue with class today. Evaluating the data on page 28. A scientific investigation always contains observation, often called data. Data are gathered during a scientific investigation and can be recorded in the form of descriptions, tables, graphs, or drawings. When evaluating a scientific claim, you might first look to see whether any data are given. You should be cautious about believing any claim that is not supported by data. Are the data specific? The data given to back up a claim should be specific. That means they need to be exact. What if your friend tells you that many people like pizza more than hamburgers? What else do you need to know before you agree with your friend? You might want to hear about a specific number of people rather than unspecific words like many and more. You might want to know how many people like pizza more than hamburgers. How many people were asked about which kind of food they liked more. And when you are given specific data, a statement is more reliable and you are more likely to believe it if it has those numerical values in it. An example of data in the form of frequency table is shown in Table 2. A frequency table shows how many types of data occur. Scientists must back up their scientific statements with specific data. Now, caution can be had here as well. Even though sometimes numbers can be used as a way in which to verify or to strengthen an argument or strengthen a scientific explanation, numbers can also be skewed in terms of how people would use those to say, see, the numbers tell us that what we're saying is actually correct. Numbers can be used to present that bias in the same way. Another way in which to evaluate data is to make sure that as a scientist, you're taking really, really good notes. Scientists must take thorough notes at the time of investigation, as those scientists in Figure 25 are doing. Even though they're underwater evaluating the coral with this grid pattern, they're taking notes with an underwater pen and probably some underwater type of paper or ink. Important details can be forgotten if you wait several hours or days before you write down your observations. It's also important for you to write down every observation, including ones that you don't expect. Often, great discoveries are made when something unexpected happens in an investigation. The next paragraph talks about your science journal. If it were given the opportunity to have different types of experiments in class, we would use some type of science journal to practice that aspect of science in which we're recording data. But because we're not given that opportunity at the moment, we're going to jump into the next paragraph. Can the data be repeated? If your friend told you he could hit a baseball 100 meters but couldn't do it when you were around, you probably wouldn't believe him. That's like Mr. Shane saying that he can dunk. Scientists also require repeatable evidence. When a scientist describes an investigation as shown in Figure 27, other scientists should be able to do the investigation and get the same results. The results must be repeatable. When evaluating scientific data, look to see whether other scientists have repeated the data. If not, the data might not be reliable. So basically, if somebody says, hey, here's what I found, but then nobody else found the exact same thing, even though they might have used the same scientific process, that type of science can often be discredited because that person might be skewing their information to have themselves look a certain way or give themselves more credit than is necessary by cutting corners and using other ways in which to show something in science. Evaluating conclusions. When you think about a conclusion that someone has made, you can ask yourself two questions. First, does the conclusion make sense? Second, are there any other possible explanations? Suppose you hear on the radio that your school will be running on a 2-hour delay in the morning because of snow. You look outside, the roads are clear of snow. Does the conclusion that snow is the cause for the delay make sense? Well, you'd say no if there's actually no snow. What else could cause the delay? Maybe it's too foggy or too icy for the buses to run. Maybe there's a problem with the school building. The original conclusion is not reliable unless the other possible explanations are proven unlikely. So you have to match up those two things. Does the conclusion make sense? Are there any other types of explanations? Our final page on page 30, evaluating promotional materials. Scientific processes are not only used in the laboratory, you probably use them each and every day, especially if you're consuming any type of content online through social media or through television. Suppose you saw an advertisement in the newspaper like the one in Figure 28. Miracle Cream makes your wrinkles disappear. What do you think? First, you might ask, does it make sense? It seems unbelievable. You'd probably want to hear some of the scientific data supporting the claim before you would believe it. How was this claim tested? How was the amount of wrinkling in skin measured? You might also want to know if the independent laboratory repeated the results. An independent laboratory is one that is not related in any way to the company that is selling the product or service. Now, this is important to note that if somebody wants to really advertise how good their product is, they'll actually send it to somebody else to get tested. That way they're removing the bias from themselves to say, yeah, we've got the best product. If somebody else says we've got the best product, it's even better for us to be able to sell those products. Results from an independent laboratory usually are more reliable than results from the laboratory paid by the selling company. Advertising materials are designed to get you to buy a product or service. It's important that you carefully evaluate advertising claims and that the data support them before making quick decisions to spend your hard-earned money. Couple examples of those advertising claims. J.D. Power is often the company associated with what would be independent laboratory results. They're going to tell you what is the best according to certain categories, and often the J.D. Power Awards go to certain types of vehicles in different categories. So the best truck or the best car. Motor Trend is another example of that. As an independent agency, this advertising or magazine company has all sorts of articles and information about vehicles, and they offer their own explanation on what they believe to be the best, rather than Chevy telling you they're the best or Ford telling you that they're the best. Here's an independent organization. You might see all sorts of advertisements like those of Flex Seal, this family of products that supposedly stops things from leaking, stops different types of problems that might arise in your house or in your vehicle, and it can be really, really helpful. Well, how do you know it actually works? You've just seen somebody on a television commercial do all sorts of crazy things that this product actually isn't even used for. So you've got to be able to evaluate, is it actually as good as they say? Because again, the end goal is them trying to get you to purchase something. So a way in which you probably use science the most is this idea that you're evaluating people's explanations of things, especially in the consumer market and the consuming economy that we live in. Hopefully this helps, and hopefully you understand a little bit more about what it means to use that scientific skill of evaluating people's advertisements to not always just believe, oh, this is the best or that is the best, and then spending your money on those things and regretting that spending later. 8th grade, now that you've finished with your reading for Section 4, you should have finished all 4 sections of your notes. In today's lesson, we went through evaluating scientific explanation and would have worked our way by completing this. Your assignment for today is Section 4's reinforcement. Top of the page, you can see that you've got this word bank, and then you've got the numbers that correspond as you read through those. Use the appropriate term in each of those blanks. For the last section, the directions ask you to answer the questions on the lines provided. Number 10, why is it important for a scientist to write down every observation, including unexpected ones? Number 11, how is evaluating an advertising claim the use of the scientific process? How are you when you're using that mindset of scientific explanation, those different types of questionings, looking at advertisements? Are you just believing everything that you see, or is there some critical thinking that needs to go into place so that you are making wise purchases in our world? Number 12, does an advertiser's claim that is the result have been verified by an independent laboratory impress you? If I'm making a product and I'm selling a product, I'm going to say, hey, buy my product. My product is absolutely the best. Or does it make more sense that if I make a product, I give it to a separate company, completely separate, I don't pay them any money, and they come back and they say, wow, sir, you made a really great product. Now, it's probably a little bit more impressive just because it removes bias in that case. Work on getting that completed, and then both your note page and your assignment page can go into Thursday's folder to be turned in for our turn-in and pickup course of this weekend and Tuesday. You don't have school on Friday and Monday, so enjoy your long Labor Day weekend. God bless.